be our second method for solving quadratic functions. And as the learning goal over here says, I can solve a quadratic function by using the square root method. This is going to be one of those methods also that's only going to work some of the times. Just like the factoring method, solving by factoring. You cannot factor every polynomial, so then you can't use the factoring method to solve a quadratic function when you can't factor it, when you can't rename it with its factored name. Sometimes we can use the square root method. Other times we're not going to be able to. We would, no matter how hard we tried, it really wouldn't feasibly work. You might try to make it work, but. So when b is equal to 0, okay, this is really important. Will you circle that, please? This is the only time you can use this. When b is equal to 0, set ax squared, or in other words, your x squared term, equal to the c term. So we're not going to have a bx term because b is 0. 0 times x is 0. So there's not going to be that bx term. We're only going to have the ax squared term and the c term. So we'll set the ax squared equal to the c. Then we will divide both sides by the a, unless, let's put over here, unless a equals 1. If it equals 1, there's going to be no reason to divide by a because dividing by 1 does not change anything, right? So we get to skip that step if a is equal to 1. And by the way, we get to also skip the first step, set ax squared equal to c, if it's not already set equal to c. So if it already is, we get to skip that step too. And then we will take the square root of both sides. Because we know that when we solve an equation, whatever you do to one side, you have to do to the other side. So if we take the square root of one side, then we have to take the square root of the other side. So here's our first one. b is equal to 0. There's no x term in it. There's just an x squared term and there's a constant. So we do not have our bx term. So we have x squared equals 25. First of all, can we skip the first step? Is ax squared already set equal to c? Yeah, it is, isn't it? Okay, how about, do we need to divide both sides by a? What's our a value? What's our a value? No? 1. So do we need to divide both sides by 1? Do we need to really go through that extra work? No. So we can go straight to the third bullet point, which says take the square root of both sides. So we will show that we're going to take the square root of x squared. Why would we take the square root of x squared? Because what is it we're solving for? X. Is the square root of x squared x? Yeah. So that's going to help us get x. So if we take the square root of x squared to get our x, which is what we want, we have to do it to the other side also. We have to take the square root of 25. Is 25 a perfect square?
Yes.
Good news. So what's the square root of 25? Yeah, I mean it is. But there's another one. Negative 5. Remember, there's always a positive square root and a negative square root. Because positive 5 times positive 5 is 25, and negative 5 times negative 5 is also 25. Anybody remember the shortcut way we wrote those? That thing up there. What thing up there?
That end poster. You see that end poster?
What color is it?
It's the green one.
The green one at the very end here?
Yep, that.
No, that's talking about, that's kind of showing absolute value.
Well, isn't that what it is?
But it's kind of saying that that one's talking about us finding the roots, and we are really finding the roots here, but that, I don't really, oh yeah, it's showing there's a positive x and a negative x, but it's not really showing the shortcut way of writing it. That one's not showing the shortcut way. And we can use the equal signs, we don't have to do any approximating. Here's what we do. Have we not done that? Positive and negative? Oh, okay, well, welcome to this means a positive and a negative 5. It has 2 square roots. It has both a positive and a negative. That's the shortcut way of writing it. So we can say that this has 2, so let's circle that and say there are 2 real solutions. So this parabola would cross the x-axis where? at positive 5 and at negative 5, right? It's going to cross at both of them. And if we move the 25 over with the x squared, so the x squared stays positive, it would open up. If we move the x squared over with the 25, then it'd be negative and it would open down. But either way, it would still cross the x-axis at positive 5 and negative 5. Okay? Questions? Okay, look at number 2. Can we skip step 1, the first bullet point? Set ax squared equal to c. Let's skip that one, right? The x squared term is already by itself. And there are no x's in this one. Okay, how about the second bullet point? Can we skip that one? No, a is not equal to what, is it? So what are we going to do to both sides? Divide by 5. So 5x squared will get divided by 5. The 245 will get divided by 5. We will end up with x squared equals what?
49.
Pardon? 49, okay. It's always a good thing when after we divide by a, we end up with a c value now that is a square, because what are we going to do to both sides now? Square root of them. So we're going to take the square root of x squared, and we're going to take the square root of 49, and we're going to show this. This is our work, showing what we have to do to get x out of there and tell what the solutions are, or the zeros, or the where it's going to cross the x-axis. So x equals positive and negative 7. So again, we have how many solutions? 2. Again, we have 2 real solutions. We have 2 places where this will cross the x-axis. Okay. Look at number 3. Can we skip the first step in this one? No. Now, we have to make a good decision, though, when we're doing that first step. Because, tell me something, can I take the square root of a negative number? Absolutely not. No. Go ahead and keep trying, but it's not going to happen. It's not going to work. So, and when you're making a decision how to get ax squared set equal to c, you're going to decide which of the terms to move. So what should we do in this one? Yeah, add 64x squared to both sides. So add 64x squared to both sides, because then our 64x squared will be positive rather than negative. So we're going to have 9 equal to 64x squared. Okay? What do we do next? There's actually 2 different moves we could make here. But typically I like to just do it the one way because it, I don't know, maybe it's less confusing. You can just kind of keep with the same process. What's our next bulleted step now? We've got the ax squared set equal to c. What would we do next?
Divide by 5.
Yeah, so we're going to divide both sides by what?
64.
Yeah, but you're probably thinking to yourself, that's going to get kind of ugly on the other side.
No,
Oh, you're not having that? Why not?
because I finished it. It's simple.
It's simple, okay.
Yeah.
After the square root is pretty
So, because in reality, what happens?
simple. Well, it'll get bigger because it's less than 1.
But do we have to worry about 9 over 64? Do we have to change it? Do we have to rename it? No. We can, and what's nice about it is it has a square numerator and a square denominator. So, oopsie, I gotta show taking the square root of these. Okay? So, we have a numerator that's a square number, we have a denominator that's a square number. Okay, now this is back when we were, I know we worked on this. When we have a fraction to a power, each of the numerator and the denominator can be taken to that power. Well, the same thing happens when you're square rooting. We also did that back a long time ago. If you have a fraction that you're taking the square root of, you actually take the square root of the numerator, you take the square root of the denominator, and what do we get? 3/8, but what else? Negative 3/8. So we get a positive and negative 3/8 for our x value. So this time it's just not crossing the x-axis, in two locations that are integer values. Instead, they are fraction, decimal answers. Okay? Now, anybody think they know what we could have done instead of the process that we're following? What do you think is that other way that I'm talking about that in reality should get us the same answer?
Pick me.
John?
What I did was I turned that fraction to the decimal, to the square root of that decimal,
I don't like that. No.
but I do
Because I'm pretty sure you do not know in your head, without your calculator, I am pretty sure that you do not know what the square root of that decimal is. Do you?
not,
But you do know what the square root of 9 is and what the square root of 64 is without that calculator.
I guess.
Yeah, so that's not the way I was thinking about. I don't really like that way, sorry. Could we take the square root of 64x squared? You know, back before we divided by that a, but instead of dividing by that a, could we have taken the square root of 64x squared? What would it be?
It would have been
8x. And then we would have taken the square root of 9, which is 3. Positive or negative 3, right? One of them has to have the positive or negative, doesn't matter which side. So we now have 8x equals positive or negative 3. But we need x alone, so then we'd have to divide both sides by 8. We'd still get the same answer.
We're pretty much doing the exact same thing, just out of order.
Just doing it in a different order. It's not really out of order, it's just doing it in a different order. Out of the order that we were doing here. Okay, what are we going to do in number 4?
The exact same thing.
What's that?
Subtract 3, divide by 25.
So we're going to subtract 3. And should we try the other way?
I think
So you can see the other way first. Should we do the square roots
That looks
first?
like it'd be
Okay, because the reason that I look at this and say, you know what, why don't we square root first? Is 25 a perfect square?
easy.
Or is 25x squared a perfect square? Is 121 a perfect square?
Yeah.
Yeah, so we actually have the option of, we could go right to taking the square root of both sides right now. We could square root first, instead of dividing by a, and then we would say, oh, this is 5x, and one of the sides has to have the positive or the negative sign. It doesn't matter which side, but since we're going to divide by 5 anyway, let's have it be on the other side. So this is going to be 5x equals a positive or negative 11, and then we're going to do what? Divide by 5. So we're going to have 5x divided by 5, and our positive or negative 11 divided by 5, which then is going to give us x equals, does 5 go into 11 nicely? No. So we could write it, leave it as an improper fraction, or write it as a mixed number, or is this a nice decimal?
Yes.
This is a nice decimal, so it does not matter, but you can just leave it like that if you want. Okay? What's the mixed number name for that? 2 1/5. So a positive or negative 2 1/5. What's the decimal name for that?
2.2.
2.2. So a positive or negative 2.2. John.
I have a question about this. So, why do you only need one positive and negative when there's two square roots?
Because if you put both of them on both sides, they would just cancel each other out, and then we would be losing the negative square root. Okay. So if we would put positive or negative 5, and then we would divide by a positive or negative, basically what would happen? Okay, here's what would end up happening. We would have to divide by both a positive 5 and a negative 5. And then on the other side, we have a positive 11 and a negative 11. So we'd have 4 division problems to do. And in the end, we would end up with still just the positive or negative 11/5. In other words, a positive 11/5 would show up twice. A negative 11/5 would show up twice. So we really don't need all of those, do we? We just need one of each of them. So it's kind of like they just end up, you save yourself work. Because otherwise you just create 4 division problems. Okay, anybody else? Okay, let's go to the back side, because now there are going to be times that there are not going to be these nice, clean-cut answers. So sometimes the number you are to find the square root of is not a perfect square. We know there are lots of those hanging out on the number line. Give me an example of a number that is not a perfect square?
7.
7.
17.
So it's 17, there's a ton of them. If we try to take the square root of a non-perfect square, it's gonna have to be approximated. So we're gonna do two things. We have to learn how to do this for geometry class next year. In geometry next year, when you are finding the square roots, you're gonna have to be able to work with them in radical form. So you need to leave it in simplified radical form. In other words, you only simplify it down until you can't anymore, and then there's still going to be a square root symbol in your answer. And that's for the exact answer. So in other words, when they say to you, give an exact answer, but yet they want it simplified, you got to know how to do that. Or we are going to round to the nearest hundredth. That's what I'm choosing what we're going to round to. We're going to round to the nearest hundredth, because if I try to take the square root of 7, it's like pi. It never repeats, it never ends. I cannot do anything but approximate it. I have to round. So I'm telling you we're going to round to the nearest hundredth for the approximate answer, or the rounded answer, if you want to use that word instead. So they tell you to approximate it. Typically they'll tell you what to approximate it to. If they don't, a good standard to go by is the hundredths place. Okay, so that first one, number 5. Is 81 a perfect square? Yeah. Is 3x squared a perfect square? No. Well, how about if we divided by 3? Well, what if we did that, divide by a step? If we divide 81 by 3, do we still keep a perfect square over there? What is 81 divided by 3?
27.
27. Is 27 a perfect square?
No.
No. So this is one of those that we're going to have to do an exact answer in simplified radical form and an approximate answer rounded to the nearest hundredth. So we're going to follow the same step we did on the front side. We're going to divide by a. We didn't notice we got to skip the first step because it is ax squared equal to c. Divide both sides by a. Now we have our x squared alone, and you told me 81 divided by 3 is 27. Now we will take the square root of x squared because we want x out of it, which means then we have to take the square root of 27. And since 27 is not a perfect square, to give the exact answer, in reality what we would have to do is say, I got the square root of 27, it's not a nice answer. But this is not simplified. Anytime, you know that number underneath that radical sign there, underneath the square root symbol? Anytime that number underneath the radical sign, the radicand it's called, is not a perfect square, you have to make sure it doesn't have any perfect square numbers that go into it. So are there any factors of 27 that are perfect squares? Mine is, isn't it? Yeah. So we can rename this as positive or negative, the square root of 9 times the square root of what? What is 9 times what is 27? 3. We can break it up like that. We did this a long time ago. We worked with square roots and being able to do some kind of things with them. Well, we can find the square root of 9, but we can't find the square root of 3, can we? Because 3 is not a perfect square. By the way, does 3 have now any perfect square factors in it? Nope. No. So now we can say that x equals positive or negative 3, radical 9, the square root of 9 becomes 3. There's no more radical sign now. But the square root of 3 can't be changed anymore. We call this the exact answer. This is the exact, okay? Now is when you're going to need a calculator to get the approximate. Now you'll put into your calculator the square root of 27.
It's going to be 5 point something.
Yeah, because it lies somewhere between 25 and 36, which are perfect squares, right? So it's going to be 5 point something.
19.
Okay, it's rounded to the nearest hundredth. So we're going to have to use the approximate, the squiggly one, approximately equal to sign, because we're showing that we rounded it. And we said it's going to be 5 point, what's the first 3 First three places after the decimal on your calculators. 196. Okay, so this is 19 with a 6 behind it. Is the 6 big enough to change this to a 20?
Absolutely.
Yeah, so then we put 20, not just 2. We put 5 and 20 hundredths. 5 and 20 hundredths, because it was 19 with a 6 behind it. 6 is big enough to round this to 20. So our approximate, or our rounded, we'll call it, our rounded answer is this one. We're going to have 2 sets of answers for these. The exact, we're going to know how to give the exact answer simplified, and we're going to know how to give the rounded answer to the nearest hundredth. So anything you want to ask questions about on that before we move on? Now I know there are calculators that simplify radicals. I know there are calculators that do it. If you wanted to simplify a radical for you, you might have one of those calculators that'll do that for you. But it would be good if you actually knew how to do it yourself. Okay? For when you don't get to use a calculator in upper level math classes. Okay, what do we have to do in number 6 first?
Subtract 64.
Yeah, we're going to get ax squared set equal to c. So we're going to subtract 64 from both sides. So we have 2x squared equals negative 64.
Wait a minute.
What do we do next? What do we do next? John, I already know what your concern is. I just want to know what we do next. Divide by 2. We got to divide by the a value. So 2x squared divided by 2, negative 64 divided by 2. So we end up with x squared equals negative 32. Well, the next step would be we need x, so we would take the square root of both sides. So the square root of x squared, that will give us x, and the square root of negative 32. Here's where it breaks down, doesn't it? Can we take the square root of negative 32? No. Cannot do. We can't do that, so we're going to have to say, you know what? There are, in our notes, let's put this, cannot take the square root of negative 32. So this is one of those that, would it ever cross the x-axis? No. This is going to be one of those parabolas that would never cross the x-axis. If it never crosses the x-axis, what do we say? Well, it's not factorable, but I mean, it could or it couldn't be, but chances are it's not. You're right. Otherwise, it would cross the x-axis. No real zeros. There are no zeros. So we have to say that. So we have to say no real solution. There is a solution for this. It's imaginary. But there's no real solution for this. There is an imaginary one. But we don't deal with that until advanced algebra, I don't think, unless they change it before then. Okay, and number 7. What should we do first? You know, we don't have to, I know that I said you want to make sure the a value is positive. It'll be okay. Let's move the 125 over, okay? So we can save ourselves one step. Let's subtract 125 from both sides, because that would move it over, correct? Caden, what would it read now after we do that?
Negative 5x squared equals 8.
Okay? So see, all is going to be well, because now we're going to do what? Divide by negative 5. So we're going to take negative 5x squared and divide by negative 5. We're going to take negative 100 and divide by negative 5. And we're going to have x squared equals, how many times does 5 go to 100? Unfortunately 20, not 25, right? 20. Is 20 a perfect square? No, this is going to be one of those, going to have to do the exact simplified and the rounded thing. So we're going to take the square root of both sides. And we're going to get x is equal to a positive or negative. Oh, does 20 have any perfect square factors? 4. 4 times what is 20? 5. Does 5 have any perfect square factors? No, so let's break it to the square root of 4 times the square root of 5. This is the trickiest part of the assignment right here. You have to know how to do this. So then, we can now say that x equals positive or negative what? What is the square root of 4? 2. The radical sign is now gone for that one. And then you can ditch the multiplication symbol. I don't know if you noticed I did that up above. We get to ditch the multiplication symbol and put it right next to the radical 5. The square root of 5. This is our what answer? No, this is our exact. So there really are only 2 solutions. But we have to give them in their exact form. And then we want to know where would that actually be about on the number line. This does not tell us a whole lot. So when we put it into our calculators now and round, we're going to round to the nearest hundredth. We're going to take the square root of 20 on our calculators. What is that?
4.4 something.
Okay, it's 4 point, give me the first 3 decimals after the 4. After the decimal point.
4.472.
472. Okay, so 47. 472. 47 with a 2 behind it. Is that 2 big enough to change this to a 48? No, so it's going to be 4.47. We got to know how to round properly also. And this is our rounded. Now we can say we know about where that is on the number line, about where it's going on the x-axis, where it's going to cross. Okay? Okay, end of that. We're out of time.